It has been observed by many scientists around the world that prescription drugs do not necessarily need to be prescribed to you to enter your system. In fact, you may be unaware of chemical drugs you consume every day. How is this possible, you may ask?
Antidepressants, painkillers, female hormones, and antibiotics are all in the water you drink. According to Shane Snyder, the professor of chemical and environmental engineering at the University of Arizona, states, "The highest concentration of any pharmaceutical we detected in U.S. drinking water is approximately 5 million times lower than the therapeutic dose." Although this does not seem like so much of a threat, he and other scientists do not know the health effects of long-term exposure.
This process began by pharmaceuticals being disposed of by being flushed down the toilet, the drugs being exerted by humans also going into sewer systems, and medical gels, creams, and lotions being washed down the drain in the shower. Liquid discharge from sewage treatment plants is released into rivers, lakes, and reservoirs. Water treatment plants then take this excess liquid and treat it as a part of the filtering groundwater. These plants may not be able to remove these pharmaceuticals, therefore they end up in your tap water.
It has been proven these harmful pharmaceuticals in our water supply endanger the lives of fish greatly. Studies show large traces of several common pharmaceuticals are in the brains, livers, and muscles of freshwater fish. As a result, the infected fish develop defects like having both male and female reproductive organs. Minnows exposed to antidepressants lost their instinct to avoid predators.
The U.S. Geological Survey was conducted and sampled 139 streams in 30 states. 80% of the waterways contain detectable levels of pharmaceuticals, insecticides, and fire retardants. Chlorine, one of the most common water filtration methods, has been proven to remove some of the drugs, while others escaped. In fact, some pharmaceuticals have been shown to react with the chlorine and create more toxic products.
For example, when combined with chloride, triclosan creates a form of chloroform, which is a human carcinogen. Because of this, soap brands containing this chemical have been banned. Scientists have tried many methods to more efficiently clean our water supply. They found adjusting pH or acidity level can improve the effectiveness chlorine has in removing some drugs. Activated charcoal proved to be extremely promising because it is extremely porous and it has an extremely large surface of area for filtration. Unfortunately, many water plants do not use this method because it is expensive to maintain and the filters must be replaced often. Ozone was also an extremely effective chemical in the filtration method, even though it is an air pollutant and its harmful effects on certain plants and respiratory systems of animals. Many companies abandoned this idea 20 years ago because of the high cost. They now cultivate bacteria to eat the drugs. While they may work, they do not consume every trace of drugs.
Shane Snyder says ultimately it has come down to people deciding how pure they want their water to be. The most economical situation might be to provide two types of water, pure drinking water and less pure water for bathing, the toilet, and washing clothes. To minimize environmental risks, you may now properly dispose of these drugs at waste removal sites. If not, neutralize them with kitty litter or coffee grounds. They may also be sealed in Ziploc bags and thrown out in the garbage. Use a permanent marker to cover up personal information on the bottle. We can change the quality of our water one step at a time. The end.